All right, let's dive into a story about two massive crises that are colliding right under our noses. A geological collapse beneath America's farmland and the hidden, massive water cost of our digital world. But what's really incredible is who broke this story first.
See, the analysis we're about to walk through didn't come from a typical newsroom. Nope. It was actually pieced together and broadcast by two AI hosts. They chewed through dozens of geological reports, climate models, and infrastructure plans to find a connection that somehow has been almost entirely overlooked.
Well, they found that this isn't just another story about a drought. It's about an irreversible physical collapse of our food supply, and a shocking new thirst from our own technology that's actually speeding the whole thing up. Let's start with the ground we stand on.
Our story begins in California's Central Valley. Now, this place isn't just a bunch of farms. It's an agricultural superpower. We're talking about America's food basket, literally.
To really get the stakes here, you only need one number: 40%. This one valley grows 40% of the entire nation's fresh produce. The fruits, the nuts, the vegetables you see in the store, a huge chunk of it comes from right here. But this whole agricultural miracle, it's built on a foundation that is physically failing.
And that foundation is a gigantic underground aquifer system. For millions of years, water from melting snow in the mountains seeped down, creating this enormous natural reservoir just beneath the valley floor. And this is a huge misconception we have to correct. An aquifer isn't some big underground lake. A better way to think of it is as a vast, waterlogged sponge. The wells are just straws pulling water out of the tiny spaces between all those sand and clay particles. But here's the thing. Right now, we're not just wringing out that sponge, we're crushing it.
And the acceleration is, well, it's terrifying. In the last century, it took 50 years for the ground to drop 28 feet. But after a few decades of stability, a return to massive pumping caused about the same amount of collapse in just the last 16 years. The rate of sinking has nearly tripled.
But the most critical part of this story, the real headline, isn't just that the ground is sinking, it's why the damage is now becoming permanent.
So the problem lies deep, deep underground. You see, the shallow layers of sand and gravel, they're kind of elastic. They can bounce back like a spring when water comes back. But thousands of feet down, you've got these ancient layers of fine clay. When the water is pumped out from there, the immense weight of all the rock above physically crushes these clay particles together, and that permanently destroys the spaces that once held water. You are literally turning the sponge into a rock.
And look, this isn't just the theory. Brand new, cutting-edge satellite data from Stanford, just published in 2024, confirmed it. Over 90% of the current accelerating collapse is happening in these deep, irreversible clay layers.
And this leads to probably the most alarming finding from the AI's research. Follow-up modeling from Stanford concluded that this collapse is now a runaway process. The damage is so deep and the clay is so dense that even if every single pump stopped today, the ground would just keep on compacting for generations. The damage is already baked in. The real-world consequence? Our infrastructure is breaking. I mean, the massive canals that deliver water to 27 million people were built on the assumption of stable ground. But as that ground sinks, the canals literally flatten and the water stops flowing. The Friant-Kern Canal has already lost 60% of its capacity. You just can't repair a system when its very foundation is disappearing.
Okay, so now let's pivot to the second crisis that the AI host connected, the invisible but absolutely immense thirst of our digital lives. Because it turns out the cloud is very, very thirsty.
You see, the systems that power AI in the cloud run in these massive data centers that get unbelievably hot. And what's the cheapest way to cool them? Water. And the scale? It's staggering. A single one of these hyperscale data centers can use the same amount of water in one day as a city of 1.4 million people. And remember, all this demand is competing for an astonishingly small slice of the pie. Over 97% of Earth's water is salt, and most of the rest is frozen solid. All of humanity, all our farms, and now all our data centers, we're all relying on less than 1% of the planet's water.
And this demand is just growing exponentially. The new hyperscale centers we need for the AI boom, they use nearly double the water of a standard data center. We are building a future that requires more and more of a resource that is physically disappearing.
So this is where the AI's analysis brings the two stories together, the geological collapse and the digital thirst. They aren't separate problems. They are two completely different industries caught in the exact same trap.
Let's just walk through this. On one hand, you have desperate farmers drilling these incredibly deep wells to access non-renewable fossil water just to survive another season. On the other hand, you have data center developers using cheap water for cooling to maximize their short-term profits. Both of these moves are perfectly logical in the short term, but both are drawing from the exact same finite, collapsing system, guaranteeing its long-term failure for everybody.
And this really brings us to the core conclusion. The entire water system for the most populous state in the country was engineered on two basic assumptions: that the ground beneath it was stable and that the water supply was renewable. And the latest science shows that both of those assumptions are now, for all practical purposes, just false.
The state's own projections are dire. If this rate of sinking continues, infrastructure failure could force an 87% cut in water deliveries for 27 million people by 2043. That's not rationing, that's a complete system failure.
Which leaves us with the unavoidable final question that this analysis posed. We have a food supply built on a foundation that is physically and permanently collapsing, and at the exact same time, we have a digital future that demands more water than ever before. One system is geological, the other is digital, but they both depend on the same disappearing resource. Something has to give. The only question is what and when.